Okay, we are back. This is Math 200. We're doing section 2.4. And so on our note packet, that is page 8. So solve mixture problems, uniform motion applications with coins and tickets and stamps and oh my, lions and tigers and bears. So let's take a look. If we had several types of coins, we could continue this process for each type of coin, and then we would know the total value of each type of coin. Okay, to get the total value of all the coins, add the total of each type of coin. Jesse has $3.02, and it's in just pennies and nickels. So how many nickels and how many pennies does Jesse have? Okay, so how are we going to do this? Well, you could just say, well, pennies plus nickels, right? So X is equal to pennies. And let's see, I think they gave us a little more information. They said, what? $3.02 worth of pennies and nickels, and the number of nickels is 3 more than 8 times the number of pennies. All right, so look, nickels, so pennies are X, nickels are a little tougher here. That's going to be 3 more than 8 times the number of pennies. So nickels equals 3 more, so plus 3 plus, and then 8 times the number of pennies, so 8x. All right? And now if we add up nickels plus pennies, we get $3.02. But wait, we can't just take this number of nickels and add that number of pennies and it's going to be 3.02. We have to put the money value in there, right? So pennies are worth 0.01, 1/100th of a dollar. Nickels are 0.05, 1/20th of a dollar. And so, okay, cool. Now let's just get our variables in there. So we've got nickels are 3 plus 8x, and that's going to be 10.05. And pennies are 0.01, and that's just x. And now, forget about all those words, forget about the pennies and the nickels and all that stuff, and just bust out your sweet algebra skills here. This is an equation. We're going to do the distributive property of the equation, and then we're going to combine like terms, and then we're going to solve the equation. So what is that? 15 cents plus 0.4 x plus 0.01 x equals 3.02. Now, depending on how much you're into this in the book, the book says, look, you could multiply everything by 100. So that would be 15, that would be 40x, that would be 1x, and that would be 302. You can do that, that's fine. You go right ahead and do that. I don't want to do that. That adds an extra step, and I don't mind working with decimals. Decimals I'm very used to, and most people are pretty used to decimals. So look, we combine like terms. That's 0.41, careful there, because right, 0.4, this is like 40 cents, that's like 1 cent. That's 41 cents plus 5 equals 2.02. All right. So remember, think in terms of money. So if this is confusing you, use the calculator. Do 0.4 plus 0.01 to make sure you get 0.41. If you got 0.5 there by accident, you took 10 cents. Then you would be working with dimes, not pennies. All right. Now we isolate the variables, subtract 0.15 from both sides. Again, it's a little tricky to do in your head unless you make change all the time. So bust out the calculator, do 3.02 minus 0.15, That's 2.87. And then we divide 1.41. Now, these are pre-cooked problems, which means I should get a whole number answer for this. Because if I don't, then they gave me a nonsense problem. So x is 7. Let's go back. What was x? X was pennies. So we got 7 pennies and a bunch more nickels, right? 3 plus 8 times 7 nickels. But let's actually calculate that. Don't just leave it like that. That's what, 56 plus 3? 59 nickels. 7 pennies, 59 nickels. Okey-dokey. All right. Danny paid $15.75 for stamps. The number of 49-cent stamps was 5 less than 3 times the number of 35-cent stamps. How many 49 stamps and how many 35-cent stamps are? So this is exactly the same problem. It's just instead of nickels and pennies, it's 35 and 49-cent stamps. All right, so here it goes. We've got 35-cent stamps are going to be X, and 49-cent stamps are going to be 5 less than 3 times the number of 35-cent stamps. So 3x minus 5. You cannot put the 5 first. Order matters with subtraction. Order doesn't matter with addition. The problem I erased, we had the plus first. I had the 3 plus, and it was fine. When it's subtraction, it's gotta be, you gotta read it carefully, because if it's 5 less than 3 times the stamps, that means the 3x has to come first and the minus 5 second. If you have those switched around, you're gonna get the wrong answer. Okay, you'll get a negative answer, which we can't have negative stamps. All right? Okay, so let's take a look. What else did they give us? Oh, $15.75. So we're going to do exactly the same thing that we did before. 35-cent stamps plus 49-cent stamps equals $15.75. Except now I'm going to put in the x there and the 3x minus 5 there. But I'm also going to put 0.35 times that and 0.49 times that. So maybe I should have said cheap stamps and expensive stamps. That would have been better. Cheap and expensive. So that you didn't see the numbers twice. Okay? So now the cheap ones are the 35 centers. So look, that's 0.35 times x plus 0.49 times 2x minus 5. And now we do the exact same problem solving that we did on the problem before. It's all algebra now. We do the distributive property. Don't forget to distribute. So we got 1.47x minus 2.45. 15.75. All right, and so we combine like terms. Again, use your calculator. 1.82 x minus 2.75. Add 2.45 to both sides to isolate the variable. Again, feel free to bust out the electronic brain. Use that calculator. That gives you 18.2. So $18.20. And then we divide by 1.82. And again, we should get a whole number here. And we do. X equals 10. So if X equals 10, 35-cent stamps equals 10. And then the 49 centers would be 3 times 10 minus 5. So 30 minus 5, so 25. So the 49-cent stamps would be 25. And again, you can double check. Go right ahead and double check. You throw the 25 times 0.49 plus 10 times 0.35 and add them together, you'll get 1575. All right? Cool. So then we're on to page 10. Distance equals rate times time. A couple of distance problems here. So when we're talking about distance, we always use dirt. Dirt. Distance equals rate times time. Where time is in hours, and distance could be in miles or kilometers or feet. It depends on the problem. And rate is, again, going to be dependent on the problem. So let's see. It says the speed of the lazy river current is 5 miles per hour. A boat travels 20 miles downstream in the same time as traveling 10 miles upstream. Find the speed of the boat. So again, we've got a current going here. And the distances are going to be the same. It's just, well, the distances are actually different. One is 20 miles and one is 10. The time is the same. You said in the same time. So when you're going with the current, here's your little boat, and it's going with the current. The boat motor is working, but so is the current. All right? When I go back the other way, I'm now fighting that same current. Current is remaining constant, but now my little boat motor is still going, but it's fighting this current. And so that actually works with airplanes too. If you've ever heard of the jet stream, they get the airplane up real high and there's always this air flow that goes across the United States. And so they actually use less fuel when they're going, I think, from never eat soggy Wheaties. When they're going from west to east, the jet stream, they ride it and they use up less gas than when they're going the other way. It's more expensive. They have to expend more fuel to go the same miles per hour. All right? Okay, so yay, little thing you learned about planes. So now look, when we set this up, distance equals rate times time, distance equals rate times time. But here's the thing, they said the time was the same. So we're going to go back to that last section and solve for t in each one of these. So distance over rate is equal to time, distance over rate is equal to time. And now we put in the distances for 20 miles. It's the rate of the boat, which is constant, plus 5 miles per hour is the stream. It told us that. Is equal to t. This one is 10 miles for the distance, but the rate of the boat, which is the same, but it's going slower because it's going against the currents. It's going to travel less distance, not going to get as far. It's going to be half the distance in the same time. All right? And now that equals time. And now they told us time was the same, so we're going to take this and substitute it over there. All right, and they have that in the notes set up. So we are going to cross multiply and solve. So I'll do that up here. So that's going to be 20 times r minus 5 equals 10 times r plus 5. All right, and now we do the distributive property. 20r minus 100 equals 10r plus 50. And now we want to get all of them over to one side. So we'll go minus 10R, minus 10R. And so we'll have 10R minus 100 is equal to 50. And then we'll red row over the 100 over plus 100 plus 100. It's important to write these steps down. Let's see, can you see those steps that I'm writing down? You can see those steps that I'm writing down. So we have 10R equals 150. And so you might say, why? Why do I have to write those down? What, do you own stock in paper companies or something? Well, first, no, I don't. But the reason that we write these down is because your brain can trick you out of the correct answer. You see minus 100. And a lot of times that's what registers in your brain. So you go 50 minus 100, you write negative 50. So that's why I always want you to write down what you're doing, even though you think it's silly or it takes too many steps. It's a good problem-solving technique that's proven to work 10 and 10. Now, if you do this for a living, eventually you would get good enough where you could just look at it and just look at this and just go, oh, it's 15. You know, you could work ahead that far. But for us, for now, I want you to write it down. So what does that mean? That means the rate of the boat is 15 miles an hour. But when I'm going this way, it's actually 20 miles per hour. And when I'm going this way, it's actually 10 miles per hour, because that 5 mile per hour current is either getting added to our rate or subtracted from it. Okey-dokey. And then, so you can pop that back in and check. If you want, for the check, you pop that right here and right there. So look at what we have. 10 is 15 minus 5 is equal to 20 over 15 plus 5. That's the check. So that's 10 over 10, which is 1, and that's 20 over 20, which is 1. So 1 is equal to 1. So it checks out. All right. Next page is Wayne and Dennis like to ride bikes. Well, that's good for Wayne and Dennis. Okay, last problem. So we're on page 11 on the note packet. They're riding bikes. Dennis's speed is 7 miles per hour faster than Wayne. Ooh, so Dennis is a speedster. All right, he's 7 miles per hour faster than Wayne. So it takes Wayne 2 hours to ride to the beach, but it takes Dennis only an hour and a half to ride to the beach. He gets a half hour more of beach time. Lucky guy. To the victor go the spoils. All right, so it's still dirt. Distance equals rate times time. So Wayne is traveling at X. Dennis is traveling at X plus 7. Whatever Wayne is doing, but 7 better. All right? So let's see here. What are we going to do? We've got the distances are going to be the same. So let's take this distance and put in Wayne's rate. So Wayne is traveling at X, and the time it takes Wayne to get there is 2 hours. Distance for Dennis, he's traveling at X plus 7, and the time it takes him is 1.5. And now they went to the same destination. They both went to the beach from the same starting point. So that means the distances are the same. So what we're going to do is we're going to say this, 2x, is equal to that, 1.5 times x plus 7. So all I did was I switched the order up, commutative property, and I wrote that in the front. We don't usually write things that are being distributed second. I put it second because that's where t was in the formula. But normally you would write it first. All right? So now forget about all the words and all the bikes and all the problems. Just do your algebra. Bust out your sweet algebra skills. 0.5x plus, what is that, 10.5? Don't forget to do that. That's probably the most common mistake I've seen in these kind of problems. After you get past the setup, everybody remembers that. Lots of people forget to do 1.5 times 7 and get that 10.5. So if you worked ahead and got it wrong, look there. That's likely what you did wrong. All right? So now what? Red Rover, negative 1.5x over. So we got 0.5x is equal to 10.5. So I don't want 0.5x though. I want 1x. So I'll divide both sides by 0.5. And x is equal to 21. So what does that mean? That means x was Wayne. And this was the rate. So Wayne rides at 21 miles per hour. And Dennis is 7 miles per hour faster on average. So it's likely (28 miles per hour on average). It's likely in the real world, Dennis, in fact, I'm sure he went 28 miles per hour at some point in the journey, but he didn't just immediately, his butt hit the seat on the bike and he started going 28 miles per hour and then he got to his destination and instantly stopped. It's not Futurama with people flying through the tubes, okay? He probably at some point went 30, 35 miles per hour and as slow as 20, 10, because he started from a stop. So it isn't like he automatically went to 28. So these are averages. These are average miles per hour. The boat one we could actually do because the boat could be chugging away at, 15 miles per hour. And we could have said at this point it was already up to speed and going 15 and it got to this point. And so exactly 20 miles up the river. The problem with that problem is the rate of the water would probably fluctuate a little bit. It usually just isn't exactly 5 mile per hour current forever. And so all of these are in the ballpark. It isn't precise, okay? So 21 and 28 is the answer there. If you want to check it, you can totally check it. You pop them back in to this formula and you'll get 42 equals 42. It turns out to be 42 miles. If you do, so if we wanted to find out, hey, how far is the beach? You could go back and say, well, here, I know Wayne is going 21 miles per hour. 21 times 2 is 42. So the distance covered was 42 miles. If you put the 28, here, 21 plus 7 is 28, times 1.5, that's also 42. So the beach is 42 miles away, but they didn't ask for that, so we didn't have to do it. All right? The next packet you see will be 2.5.